All right, pretty straightforward today. Students will be able to find the slopes of parametrized curves. So slopes of parametrized curves. If all three derivatives exist and dx dt does not equal 0, because you cannot divide by 0, then dy dx is equal to dy dt over dx dt, because if you multiply the top and bottom by the differential dt, those would cancel and you would get dy over dx. But parametric curves have an equation for x and an equation for y. So here we see in example 6, find the line tangent to the right-hand hyperbola branch defined parametrically by that. Now this is a hyperbola, if we were to graph it in parametric form. At the point square root of 2, 1, where t is pi over 4. So all we're doing is find the line tangent. We already have the point, now we just need the slope. In other words, we need dy dx. In other words, we need dy dt over dx dt. Because we don't have a derivative of y with respect to x. We don't have a y equals 7x plus 3. They're in t's, secant of t and tangent of t. So the derivative of y is secant squared. The derivative of x is secant tangent. We're going to evaluate this when t equals pi over 4. So it's literally the derivative of the function y over the derivative of the function x. Oh, secant of pi over 4. Pi over 4 is square root of 2 over 2, square root of 2 over 2. Oh, I can cancel some of these out, by the way. Probably did this a little too early. I can go, this is secant over tangent. That'll make it a little easier. Now I'm going to evaluate when t equals pi over 4. Secant of pi over 4 is 2 over square root of 2. It's the reciprocal of cosine. And tangent's 1. So square root of, let's see. With trig functions, we usually rationalize. You wouldn't have to. So it ends up being just square root of 2, by the way. So there's the slope. So the answer is y minus 1 equals square root of 2 times x minus square root of 2. So the only thing really new there is that the derivative is the derivative of y over the derivative of x when they're parametric curves. Everybody good? All right. Let's talk about the unit circle, because if we're doing, they like to throw in trig functions with this. So I give you a copy of the unit circle. You have it now. So you can refer to that if you need to. For the test, you will not be given that. Secant of pi over 3. So pi over 3 is here. Secant is the reciprocal of cosine. So this is 2, reciprocal of cosine. Tangent is sine over cosine. Square root of 3 over 2 over 1/2 is just square root of 3, because the 2's will cancel out. We can multiply the top and bottom by 2. Those cancel, square root of 3. Cosecant of pi over 3 is the reciprocal of sine. That's 2 over square root of 3, 2 square root of 3 over 3. We usually rationalize unit circle values. Cotangent is cosine over sine. So that's 1/2 over square root of 3 over 2. That's 1 over square root of 3, because the 2's will cancel. So square root of 3 over 3. So what would cotangent over cosecant be? Cotangent over cosecant. Now I wouldn't use the rationalized part. I would do 1 over square root of 3 over cotangent over cosecant over 2 over square root of 3. That'd be 1/2, because the square root of 3's would cancel. So you might be asked to do that, because if you have the derivative of y over x, it ends up being cotangent over cosecant, and have to evaluate this. At least we've seen it once. Quick review of the unit circle. I will expect that you know the unit circle. Now, if we get to a problem and I do one, you're like, oh, wait a minute, where'd you get that? I'll review all day long with you. But I'll expect you to know this unless you ask me, hey, I'm having a little trouble with this part of it. Students will be able to find the equation of a tangent line of a parametric function. Old question, new derivative. So find the equation of a line tangent to the curve at the point defined by the given value of t. We need a point, and we need a slope if we're going to find the equation of a tangent line. Now to get the point, we're going to plug pi over 4 in for the t's to find x and y. So x is equal to 2 cosine of pi over 4. That's 2 times square root of 2 over 2. So square root of 2. Y is going to be the same answer. 2 sine of pi over 4 is 2 times square root of 2 over 2, which is also square root of 2. So that's just finding the point. We're going to plug in pi over 4 into x and y. Then the slope dy dx is the derivative of y, 2 cosine of t, over the derivative of x, which is negative 2 sine of t. So the 2's are going to cancel. Cosine over sine is negative cotangent of t. Now you wouldn't have to simplify this because we're evaluating it, but I mean either way you're going to get the same answer. So we're evaluating when t equals pi over 4. So negative cotangent of pi over 4 is negative 1. Sine over cosine at pi over 4, or cosine over sine that is, that would be 1. Slope is negative 1, so here's the answer. Y minus square root of 2 equals negative 1 times x minus square root of 2. So there's the equation of the tangent line. The only thing new, like I said, is the derivative, and it's a derivative of y over derivative of x. It's very straightforward. You got to know derivatives of your trig functions. You got to know the unit circle. So maybe that's all of that combined makes it, you know, a little tricky, maybe a little difficult. Number 43. We need a point and we need a slope. So we're going to plug negative pi over 4 in for the t's. Negative pi over 4. That's kind of nice. We love pi over 4s because it's the same thing. That's square root of 2 over 2, negative square root of 2 over 2. So there's a reminder of where negative pi over 4 is. X equals secant squared of pi over 4 minus 1. So we are squaring square root of, no, that's sine. Can I back up? There we go. 2 over square root of 2 squared minus 1. Secant is the reciprocal of cosine. And cosine's positive. I got that. I'm squaring it, so that wouldn't have mattered. 4 over 2 minus 1, 2 minus 1, 1. So you square it, you get 4 over 2. 2 minus 1 is 1. So the x-coordinate is 1. Y equals tangent of negative pi over 4 is equal to negative 1. Because if you divide those, you get negative 1. All right, negative 1. Here's the new stuff. dy dx is equal to, the derivative of y is secant squared. The derivative of x would be 2 secant of t. So the outside function is squared. Multiply, reduce the power by 1. Derivative of secant is secant tangent. And then the derivative of t is just 1. So it looks like this reduces to 1 over, see, those two cancel those two, over 2 tangent of t. There's dy over dx. We're going to evaluate this at negative pi over 4. So that's 1 over negative 2, because tangent of pi over 4 is negative 1. So negative 1/2. The answer, y plus 1 is equal to negative 1/2 times x minus 1. Old question, new derivative. We'll do that a lot. Old question, new derivatives. Here's a new question. It says let y equal x squared plus 7x minus 5. Evaluate dy dt when x equals 1 and dx dt equals 1/3. Well, this goes back to what we said right at the very beginning. We said that dy over dx is equal to dy dt over dx dt because we could cancel those dt's and it'd be the same thing. Well, that's exactly what we're going to do here. We're going to say that dy dx is equal to dy dt over dx dt. I mean, are you picking up on the notation? Is this sinking in at all? I mean, I felt like I focused on the notation a lot. What does that tell you to do? What is dy dx? Derivative of y, right? That's what it tells you to do. So we're going to take the derivative of y with respect to x. So 2x plus 7. That's what it tells you to do. That's the derivative of y with respect to the variable x. Equals, we're asking for dy dt, so we'll leave that alone. And they tell us that dx dt is 1/3. So I have, I have one. It seems like we have two unknowns, but I only have one because they're telling us to evaluate this at x equals 1. So 9 is equal to dy dt over 1/3. So we multiply by 1/3. So the answer to the question, dy dt, is 3. 1/3 of 9 is 3. Ironic, I think if I were asked you to do this problem without having to explain it, I think it would be a difficult problem for you. Hopefully it's not now. Hopefully I've explained all the parts and the pieces. But the interesting part I feel about calculus sometimes is the only calculations we did is we took 2 plus 7 and then we took 9 divided by 3. That's the calculations we did. That's it. We added two numbers and we divided two numbers. That's it. But it's a pretty rough, it's a tough problem before you kind of see how it's done. So you got to know, you got to pick up on this notation. I don't do anything up here just, I'll just throw this at them for fun. You know, when I'm talking about notation, you need to know that. All right, if you're watching this video at home, if you've been gone, the rest is kind of review. So if you want to keep watching, that's great. But that's it. That's the material for today. There's not much left over. This is day 4 of the section, by the way. So we had a little bit left over with parametric. Take the derivative of y over the derivative of x, you guys, and you got it. Should we practice the gateway? Try the first one. Well, I guess there is a new problem down at the bottom. I should probably put that, switch the order of that. There's the first one. Secant squared of x squared minus 1 times 2x, chain rule, of course. This is the one that causes a lot of students to have to retake the gateway. It's first times the derivative of the second, and times 2, right? Times 2. Don't forget the chain rule on this one to the right. Multiplying by 2 is the easy one to forget. Plus second times the derivative of the first. Cosine 2x and then times 2. Times 2 again, I remembered we can factor out a 2. And that'll be, I'll write it like this, cosine of 2x minus sine squared of 2x. And that is the double angle formula for cosine. So the answer is 2 cosine of 4x. You double what's in here. And that'll be your answer. That'll be full credit answer there. Second derivative of this one, y prime, is equal to, well, let's do this. 4 secant squared of x over 5. There's the derivative of tangent, but the derivative of 1/5 x is 1/5. So times 1/5. We got 4/5 secant squared of x over 5. The second derivative now, we just created 3 functions. We had 2 functions before, tangent, and then the inside was x over 5. Here we have 3. So the first outside function is squared. So 8/5 secant of x over 5. So multiply by 2, reduce the power by 1. There's the first part. Next function is actually secant. It's picture day, so they're doing a little announcement. So secant of x over 5, tangent of x over 5, that's the derivative of secant. And then finally, the derivative of the innermost is 1/5. So we can clean this up a little bit. 8 over 25, secant squared of x over 5, tangent of x over 5. Yeah. Okay. Any questions on this one? The one over here, it's a little tricky, but this is x to the, what is that, 10 halves and 1/2. This is, 11 halves. This problem is pretty straightforward if you just change that to powers, or one single power, because then the derivative is 33 halves x to the 9 halves. So 33 halves squared of x to the 9th. If you try to do the product rule on that, you can get the right answer, but it's a lot harder. It's a lot harder. Find the derivative where t is equal to 0. So we're just finding dy dx. So dy dx is equal to the derivative of y, which is 6t minus 4, over 5 cosine of 5t. So derivative of y over the derivative of x. We're evaluating when t is equal to 0. So we're looking at negative 4 over, let's see, cosine of 0 is 1, so 5. Looks like negative 4/5. So it's literally the derivative of y over the derivative of x. Turn this into Google Classroom. I will reveal the answer when I think everyone's got it done. Grab your phones, take a picture of it, upload it to Google Classroom, please. And I'll make sure I have that assignment in there. Signing off.